well start off with some great puns. A neutron walks into a bar and asks how much a drink is. The bartender says, "For you, no charge." You guys get it? Sorry, you must not have heard me. I said no charge, because neutrons are neutral, but the bartender, he's inferring that, or he's implying that he doesn't have to pay any money for the drink. Do you guys get it? I feel like you're not getting it because you're not laughing really hard. Okay. All right. Good talk. All right. Okay. What about this though? Cat ion, a little positive, and ion with a pause. You guys get it? That's not how we spell positive. It's supposed to be POS, you guys. All right. Whew. Got it out of my system. Good talk, everyone. Good talk. All right, Uzama, stop crying, laughing. It's not that funny. Like, I know it's funny, but it's not that funny. All right, calm down. Take a deep breath. Okay, all right. This is you. This is your life. Atomic structure bell work number 2. I'm asking you to do the top half and the bottom half right now. And let me mention this. You have a quiz on Friday. One of the questions on your quiz will be a chart identical to this with just different numbers and elements, where if you need like number 36, you'll like grab it from down here and you'll like drag it into one of these boxes. Does that make sense? Okay. So you will be completing a whole chart just like this on your quiz on Friday, and you'll also be completing a whole section like this on your quiz on Friday. Does that make sense? So this is great practice to get you ready. I'll give you guys a couple minutes to get cooking on this, and then we'll move on. Go get them, nerds. Now, before we get talking about this bell work, I do want to mention a couple of things. I've said this once already, I believe. I just want to be very clear, okay? Next week, when we are all remote, no matter what, okay, including myself, I can't even be here. The Monday folder and the Tuesday folder will both have a recording in them. You will watch them. You will take the 3-question quiz for each one, okay? I will have both Monday and Tuesday posted, honestly, probably by like Sunday. So you can watch it all on Sunday. You can watch them all on Monday, all of them on Tuesday. I don't care. But just make sure you take care of those quizzes nice and early, because it's very likely that you'll forget if you don't do them right away, because it's a break season, that kind of thing. So just please be careful about that. But anyways, let's go ahead and talk about this bell work, which, as I mentioned, will be just like your quiz on Friday. One of the questions are for your quiz on Friday. Somebody tell me a question they would just love to go over. Which row? 1, 2, 3, 4, 5. Uh-huh.
Try the 1, so I don't get called on.
So which one?
1.
Number 1?
Selenium.
Okay, selenium. Let's see here. What's the atomic number?
34.
You got it. So the moment you find atomic number, what else do you also know without having to do any math? That's right. Which is what?
34.
You got it. Love it. Okay. What does the charge of this guy have to be?
I think I got it that wrong though. I feel like -2, but I don't think it was.
That is correct. A couple of things to keep in mind for you. Charge will always be equal to your protons minus electrons. So if you have more electrons than protons, it will be negative. Like in this case, you have 2 more electrons than protons. If you have more protons than electrons, it will be positive. And you have the same of each, it will be neutral. Another equation to keep in mind is that mass will always be equal to protons plus neutrons. Do you guys see how protons are involved in the mass and the charge? That's why they're by far the most important part of an element. That's why they are what are used to define the element. So in my mind, I'm always trying to find the protons as quickly as possible, because it sort of unlocks everything else for me. Yes, what's up?
When they explain like how they found something, can you repeat it because we can't hear them?
Oh, sure. So like the charge?
Yeah.
Okay. Well, in this particular case, we know that there are 34 protons. We see that there are 36 electrons. That was given. And so the charge must be -2. Does that make sense?
Yeah.
Okay. There you go. Yep.
So when you have a zero charge, does that mean that the number of electrons is equal to the number of protons?
That's exactly what that means. Correct. Good question. Alrighty. And then what did you get for the mass here, Zana? I'm sorry. My apologies. The number of neutrons.
45.
45. And where did that come from?
I subtracted the mass number from protons.
Yep. So if mass is equal to protons plus neutrons, we know the mass is 79. We know the protons are 34. So in other words, 34 plus what equals 79? You can subtract the 34 on both sides. And this will come out to be 45. There we go. Not bad, not bad. Let's do the fourth one. The fourth one's definitely got the most sauce. So in the fourth one, we see that we don't know what element it is. We're not given its atomic number. We're not given its number of protons. We're not even given the number of electrons. So we're like, okay. So I really have no idea what's going on. Like I mentioned earlier, I strongly encourage you to always find the protons first. It's by far the most important piece of information. So I do have a mass. I do have neutrons. Okay, I got a mass and I got neutrons. So I know that I can use those to get the protons. So that's exactly what I'm going to do. My mass here is 13. I don't know what the protons are, but the neutrons are 7. So 7 plus what is equal to 13? 6. So I must have 6 protons, and immediately I know that's my atomic number. What is the only element that has 6 protons in the universe? Carbon, that's right. And then for the number of electrons, a lot of people are like, okay, so there's plus 4, so is this going to be 2 electrons or 10 electrons? That's where people kind of get stuck. They're not sure whether they're add or subtract. So 2 ways to think about this. If it's plus 4 plus for the charge, that means there's more protons than electrons. How many more protons? 4 more protons. Okay? So you can think of it that way, or you can just plug it into the equation. The charge is plus 4, number of protons is 6. Minus the electrons. So 6 minus what equals 4? 2. There we go. Some people will put 10 there, but if you're paying careful attention and you're thinking about what you're doing, you should conclude that there's a 2. All right. Now on this part right back here, so again, you'll have something just like this on your quiz. The difference between these guys, these are isotopes, so the only difference between them is their mass. Okay? So everything else should be the same. So strontium, it's element number what? 38. So it's got 38 protons. So both these will have 38 protons no matter what. Let's see here. Okay, this is strontium 84, so it's got a mass of 84. 38 of that came from the protons. So that means it must have 46 neutrons. Whereas this one over here is strontium 88. Again, 38 of that still comes from the protons. That leaves 50 for the neutrons in terms of mass. Uh-oh. That's not what I want to do. Okay. Now, do either one of these have a charge? No. So let's see here. Hey, Miss Lacker, if neither one of these have a charge, what does that tell you about the protons and electrons? You got it. So there we go. 38 electrons. 38 electrons. Now, with this right here, it's just asking you to list the total mass. So this is just 84. And this one, it's 88. There we go. You will have a setup exactly like this on your Friday quiz. Okay? Yes, ma'am.
Why isn't electrons like the charge?
Yeah, electrons and protons affect the charge. So protons are +1, electrons are -1. So those are the 2 things that factor in the charge.
So why wasn't the electrons written as +4 in the first one?
In the
Because it was 2 in the first one.
in the previous problem
No, like the one that you just did.
with strontium. So why not write +4 for the electrons here?
No, because for
Oh, okay. Well, if there's 38 protons right here, that's a charge of plus 38. So you need 38 negative charges here to cancel out and get a charge of 0 overall.
Oh, okay, so the plus 4 is the mass of neutrons.
Yeah, so this right here, that's a mass. These two numbers are a mass. They're not charges. Charges will be in the top right hand, and they'll have either a plus or a minus before them. Does that make sense?
Yes.
Yep. Okay, there we go. Glad we got that settled. Boom, 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 boom. Okay. So just to sort of emphasize, we had the difference was right here in the neutrons, and that was causes the change in mass. All right. So yesterday I asked you guys to do some counting. Let's see here. You can check your counting right here. I'll leave this up so you don't have to check all your counting right now. Here's all the counting that we did. I want to do one more of these problems before I let you guys go on your own, kind of work on this. So let's look at this next one. Okay, so we have 14 protons, 16 neutrons, 14 electrons. All right, Grace, I'm going to pick on you for this one. This has 14 protons, 16 neutrons, 14 electrons. So what's the mass for this particular one? 30. Where did the 30 come from? Why'd you do 13 plus 16? Or 14 plus 16?
Because the mass is the neutrons minus.
Yeah, mass is protons plus the neutrons, right? Because protons have a mass, neutrons have a mass. Do electrons have a mass? No, so we don't factor them into that calculation. So you're taking this guy and this guy, you're adding them together to get that 30. Okay? What element does this have to be, Grace, if it has 14 protons, 16 neutrons, and 14 electrons? Okay, and what number is the key factor to that? 14 what? Protons, right? The protons give you the identity. So this has to be silicon because of the number of protons. The symbol for silicon is Si. So here, when we're doing the full atomic symbol, I'll start with my Si. My mass goes up here, so this particular one is 30. This particular one is 30. Now, go ahead and take a look at silicon on your periodic table. Look at number 14. Okay? What mass is silicon usually? It's usually 28, but this particular one happens to be 30, okay? So please keep that in mind. The periodic table tells you what a normal or typical particle is, but that doesn't mean what the one you are working on is, okay? So it's got atomic number 14. And the charge, remember charge, is equal to your protons minus electrons. In this case, we have 14 of each, so that'll come out to be a 0. Mr. Pilcher, do I have to write the 0 for charge? For right now, yes. Because if you leave that blank, I won't know if you just got lucky or if you understand it, there's no charge. Eventually, we won't have to write the 0 for no charge, but for now, we do have to write the 0 for no charge, okay? So, on your quiz on Friday, you will be given a picture just like this one. If you guys kind of remember this from yesterday, it's in your slides, that sort of thing. It'll be a brand new picture. I literally made the Petri dish yesterday, okay? It'll be a brand new picture, and ultimately, you're going to have to get the full atomic symbol. So you're going to have to be able to recreate what we just did right here. So you're going to have to be able to get that full atomic symbol for that problem, okay? So if I give you a picture of a Petri dish with the beads, you got to give me the full atomic symbol. Now, turn to part 5 for me because you're going to have to work on part 5 today as well. I just want to clarify something. Okay, so this is part 5. This is at the bottom of that next page that we were just on. So, this is an isotope chart that's going to help you compare the isotopes of 2 different atoms. Now, this section right here, these 2 middle columns I have highlighted, those are asking you about the typical particle from the periodic table. Okay? The typical particle from the periodic table. This guy right here, this section I have in blue, That's not asking about the typical particle. That's saying, hey, what about this one? So for example, this guy right here, carbon 14, find carbon, it's element number 6 on your periodic table. Its typical mass is what? 12, right? So the mass number on the periodic table, so you're right here, you're like, okay, usually it's carbon 12, which means it usually has 6 neutrons, but this guy, carbon 14, has an 8. So this is helping you compare the difference between the usual on the periodic table and an atypical one that you're currently dealing with. Does that make sense? There's one thing I would like you to change on this, right here. So number 235, scribble it out. You'll have to fill it in yourself. But I want you to write uranium 235. So that 235 was supposed to be in this box, not the far right-hand one. Okay? So I want you to finish parts 3, 4, and 5 today while you're in class. Okay? So 3, 4, and 5. Now here's what's going to happen. Everyone should go get their participation points right now before you forget. So live folks, virtual folks, Wednesday folder, get those participation points, get that 10 out of 10 before you forget. Virtual folks, I'm going to check in with each one of you, make sure you're doing all right, and then I'll let you go. Live folks, I'll come check in on you guys after a little bit, okay? All right. Ms. Lacker, do you need help with anything right now? Do you have any questions? Okay. Well, make sure you get your participation points. Fill out parts 3.